Hello, today while I'm gone, you have 3 things to do. One is to complete the notes on the front of the page of the types of energy. The second, you're going to do the analyzing model changes in energy packet. It's a POGL activities to work through with a small group. And then there's a reading assignment in your packet on kinetic potential, elastic, and gravitational potential energy. So before you get started on the last two, we want to get some basic definitions down for energy. One of the problems with energy is it's a tough concept to define. If you Google what energy, a science definition of energy, oftentimes you'll find the ability to do work, and then you look up the physics definition of work, and it will be the ability to transfer energy. It's the cyclical definition, and neither one actually tells you what it is. Energy is something that we can quantify, we can count, we can put a number to it, and we'll learn later that it always stays the same. So it can change from one type to another, but the total amount always stays the same. So it's really useful for looking at how our objects interact with each other and making predictions as to what's going to happen. Everything has energy, and you're going to see it brought up in biology and chemistry. It's a topic that's going to keep coming back to you as you go through science. The way I will define energy for this class, and it's kind of a helpful way to think through how much energy something might have, is the ability to cause pain. Because most things that have energy can cause you pain, or a lot of things that have energy can cause you pain. As we go through the types of energy, some of these will sound familiar. We might be putting a little bit more of a upper level definition on them and looking at them a little bit more in depth than you have in the past, but many of these are words you might have heard of in a previous class. Maybe, maybe not. The first type of energy that a lot of kids will throw out if I ask them for types of energy is kinetic. So a lot of kids seem to have learned about kinetic energy in science or at some point in their life. The symbol we will use for all of our types of energy is E, and then we'll use a subscript like we did with forces to specify which of the different types of energy it is. So for kinetic energy, since it's the K, we will do EK. This equation column here, we will fill in later as we work through the unit. And so just leave that blank for now. And then for notes, we want to know what things can affect how much kinetic energy has. So if we go to that idea that energy is the ability to cause pain, moving objects have kinetic energy. So kinetic energy is stored in moving objects. If we were in class for this, I would often throw a ball, not actually throw the ball, but I'd have a ball and I'd say, what can I do to cause this more pain if I was to throw it at someone? Because if I throw the ball, it's moving. And if it was to hit you while it was moving, it would hurt. It would cause pain. So the things that would change how much the ball would hurt you would be how heavy the ball is, how much mass it has. You can also, use the word weight, but mass is a little better here. And how fast it's moving. So kinetic energy depends on speed. And mass. So the faster it goes, the more energy. Sorry, it's getting a little messy there. Squeezing it in too much. And the heavier it is, the more energy. Second type of energy that is potential energy. There are two types. Actually, there's a lot of types of potential energy, but there's two types that are going to show up for this class. The first is going to be gravitational potential energy. This is the type that most kids think of, I think, when I say First they say potential and I say what type. And then this is, I think, what most kids are thinking of when they think of potential energy. So we always need to specify if it's gravitational potential energy or elastic potential energy. For gravitational potential energy, just like gravitational force, we use Fg. Gravitational potential energy will do Eg. Gravitational potential energy is energy that is stored in an object above a height of 0. So if I held a ball above your head and dropped it, it would hurt. So if that's the case, we might be calling your head a height of 0. Height of 0 is something we'll talk about later, but we can call anything a height of 0. Typically, we use the ground since that's the lowest height an object will get to. So when we define what things are right, what things can have gravitational potential energy, we'll say it's stored in objects above a height of 0. It's a relative amount of gravitational potential energy. And then think about what could I change about a ball if I was to hold it above your head and drop it, what things would cause it to hurt more. So most kids will say, well, how high I hold it, so how high it is and how heavy it is. So if I was to drop a ping pong ball on your head, it wouldn't hurt very much. But if I was to drop a bowling ball on your head, it would hurt more because a bowling ball is heavier. So it depends on height. And mass. So higher is more energy. Heavier is more energy. Elastic potential energy, we're going to do EEL. And then that is stored in things that are stretched or compressed. So that's like elastic, can stretch or compressed. There's another bit here that sometimes I'll add in the notes. I'm not going to write it today, but that needs to want to go back to its original shape. So if you can say you can stretch or compress Play-Doh, but Play-Doh isn't going to magically spring back to its original shape once you stretch it out. It stays in that shape. So that's not elastic potential energy. But if I take a rubber band, this is probably the most common example of this. If you take a rubber band and stretch it, it will want to go back to its original shape. And if I take that rubber band and pull it back and aim it at you and it hits you, it could potentially cause pain. Maybe not a lot, but it could hurt a little bit. So the farther back I stretch it, the more it would hurt when it hit you. And then there's also something, it's a little hard to put into words, but some rubber bands just are a little harder to stretch or a little tougher. There's something called a spring constant that describes how hard it is to stretch something. It's independent. It's depends on the object itself. And so that can affect it too. So, but for what can affect it, we're just going to put the distance, how far back you pull it. And then the fourth type of energy, this one is sometimes a little tougher for kids to come up with when I'm asking for volunteers to give me examples. The fourth type we're going to see a lot this unit is thermal energy. This one is a little different than others in that when we start talking about energy changing forms from one type to another, kinetic, gravitational, and elastic all easily convert from one to the other. Thermal doesn't. So once one of these types of energies become thermal energy, it often stays as thermal energy. It almost always does. So we'll talk about that in a couple of days when we start making pie charts and showing how energy changes. But thermal energy is stored in things that it's stored in the, like, I don't know how to put this into words easily, but there's this random motion of particles. So everything, we know everything's made up of atoms, and those atoms are always moving around. That random motion of energy is the thermal energy that it has. So the hotter it is, the more thermal energy things have. Oftentimes, what helps a lot of kids is just to think about it as heat. Not technically the same thing, but we will use that. So heat and thermal energy are similar, but the way we're going to define it is what I said earlier, stored in this random motion of moving atoms and molecules. The analyzing changes in energy activity has a good way of showing this, and I really like it for that. That's one of the things I like about that activity. So when you're doing the part with hammering clay with a hammer, they're going to have you drawing the random motion of molecules, showing how the kinetic energy of a hammer gets changed into heat. The hotter things are, the more thermal energy they have. The more the particles will move, the faster the particles will move. So the warmer it is, the more thermal energy. So once you have these notes down in your packet, then get with a small group and work through that modeling changes in energy packet. And then there's a reading assignment on pages, I think it's pages 4 and 5, but I'll have the pages in the slides to complete. The packet turn in when you're done, and the reading assignment I'll check on Wednesday for completion. Will give me